Welcome to the PDB Art Exhibition 2022. The PDB Art Project is an outreach initiative involving 9 schools, 2 art societies, and the Protein Data Bank in Europe. We work together to inspire school students from 11 to 17 years old to learn about the 3D molecular structures in the PDB and use them to inspire the creation of artworks as part of their art curriculums. Students learn to explore and research their protein of interest and create artworks accompanied by descriptions which are showcased in this exhibition. This tour will introduce you to some of these artworks made by these young artists last year. Year 8 students from Thomas Gainsborough School created these colorful paper sculptures based on fluorescent proteins. Fluorescent protein molecules absorb radiation and emit light, making the organism look like it's glowing, often seen in jellyfish, coral, and sea anemones. Some fluorescent proteins are photoswitchable, meaning the organisms can turn the fluorescence on and off like operating a light switch. This year we saw 3D artworks created by Year 7 students from Eubank College, Australia. They worked in pairs to create their artwork. This glowing firefly sculpture created by Joanna Chan and Isha Patel portrays the bioluminescent luciferase protein. This enzyme catalyzes a reaction in which the chemical luciferin reacts with molecular oxygen to create light. The most inspiring thing for Joanna and Isha was being able to see the proteins as well as to see firefly come to life by adding the LED lights. At Perth School in Cambridge, Year 9 students learned about the biology and structure of 3 proteins: hemoglobin, keratin, and salivary amylase. The students use this knowledge and explored through the PDB archive to create artworks in their art lessons. They choose to create many different forms of artworks using prints, etches, Photoshop, and glasswork this time, which are showcased in this exhibition. This artwork by Zara Osai on human salivary amylase was inspired when she was learning about proteins and enzymes in biology lesson. Amylase interested her especially since it breaks down starch into simple sugar. 2 main elements to her final piece are showcased here: a print created by etching and a glasswork which trapped copper leaf wire and oxide meant to symbolize the diversity of the amylase protein. Ribozymes are RNA molecules that catalyze specific biochemical reactions, including RNA splicing and gene expression, similar to the action of protein enzymes. They are like fossil records of the ancient molecular evolution of life on Earth. This 3D art by Janelle Bankus of the Lee School highlights this small hinged hairpin ribozyme. Year 12 students from the Stephen Peirce Foundation School each picked up their own topic of research related to protein structures. In this artwork by Thanak Korn is based on her research into spiral seed pods and the protein lipooxygenase that is found in soybeans. Lipooxygenases are large iron-containing enzymes in plants, animals, bacteria, and fungi. These catalyze the oxidation of fatty acids to produce highly reactive hyperoxides. These hyperoxides are capable of altering the flavor, aroma, and appearance of food. They are therefore sometimes used in food and beverage industry to improve the physical and chemical characteristics of ingredients. We are now going to explore some artworks by Year 10 students from Leaventhorpe School, Sawbridge. The students chose the theme of emotions and created artworks based on proteins affecting emotions. Here, Charlotte is inspired by the protein serotonin. It is known that laughter accelerates circulation and helps muscle to relax, in turn reducing stress. This is due to the release of protein called serotonin. It is understood that serotonin impacts animal cognition and behavior. Deficiency in serotonin can predispose birds to develop feather picking. This inspired Charlotte to create her artwork based on serotonin and the bird toucan. Keratin, that is found in feathers, wool, horns, hooves, hair, claws, beaks and hair of animals, is a simple coil-coil helical structure rich in amino acid cysteine. It has the ability to self-assemble into bundles of fibers. This natural protein shows immense biological stability, which proves strength to our internal organs and maintains elasticity of our skin. Roisin chose this protein because keratin is what peacock's feathers are made of, and linked it to the appearance of the peacock. This year, Year 12 students of Saffron-Walden County High created artworks based on the theme of glowing proteins like luciferase or GFP. Here, Oscar Haigem took inspiration from the graphic artist M.C. Escher, whose art explores topics such as perspective and symmetry, and Oscar based his artwork on light-emitting fishing rod of anglerfish who have mastered a trick to light up the great depths of our ocean floors. Year 12 students from the Lee School each picked up their own topic of research. This textile work by Amelia Mitchell features a ball of wool depicting deposits which form tangles in Alzheimer's disease. In this progressive neurodegenerative disorder, the brain slowly loses memory and cognition, and eventually the patient is no longer able to carry out simple day-to-day tasks. It is thought to be caused by the abnormal buildup of proteins in and around the brain cells. One of the proteins involved, called amyloid, can accumulate to form plaques around the brain cells. Another protein called tau forms tangles within the brain cells. Amelia exquisitely portrayed both of these proteins in this piece. While drugs may improve memory and reduce confusion moderately, there is still no cure to stop Alzheimer's disease from worsening over time. With this, we have come to the end of the guided tour today. Please take time to explore the other beautiful artworks which are showcased in this exhibition. Thank you.